Hello, my name is Malek Ben Hammouda. I go to Washington Liberty High School in Arlington, Virginia. I did a raw data analysis on the relationship between exposure to fine particulate matter during pregnancy, commonly known as PM2.5, and preterm births. Particulate matter is a very common pollutant found in the air that most people inhale every day. It ranges in size and origin. However, they're all caused by a chemical reaction between solid particles and liquid droplets in the air. In this analysis, a specific type of particulate matter was focused on, fine particulate matter. Like mentioned earlier, fine particulate matter is commonly known as PM2.5. This is because fine particulate matter has a diameter of 2.5 micrometers or less. Its small size makes it easily able to penetrate into one's lungs and bloodstream, causing a variety of health issues. However, when pregnant, not only may exposure to fine particulate matter affect the mother, but also the embryo. Because of this, the analysis was conducted to determine if there was a relationship between exposure to fine particulate matter during pregnancy and preterm births. This project was chosen because a very close aunt of mine lost her newborn due to sudden preterm labor. During screens, the doctors weren't able to find any health issues with the mother or the embryo. This made me question if there are controllable factors that may lead to preterm births. A significant reason why exposure to fine particulate matter is especially dangerous for the embryo is because the detoxification system of the fetus isn't strong enough to eliminate all pollutants and toxins that come its way. This weakens the placenta surrounding the fetus, which increases the chance of early life morbidity or mortality. Because of this, it was believed that if gravida exposed themselves to higher amounts of fine particulate matter, then higher rates of preterm births will occur. This analysis was conducted using raw data from the Environmental Protection Agency for the Air Quality Index scores regarding PM2.5 and the Kids Count Data Center for the number of preterm births. Raw data for both variables was collected in Alaska, California, Pennsylvania, Oregon, Texas, Utah, and Washington between 1999 to 2017 in intervals of every other year. In order to get an annual air quality index score per state, the air quality index scores for every day of the year in every county of the corresponding state was averaged out. This resulted in 70 raw data points for air quality index scores, 10 per state. Another 70 raw data points was retrieved for the number of preterm births per state annually. The air quality index scores and the number of preterm births were each averaged out across the 10 years in order to get 14 summative data points, 7 per variable. In the first image is a portion of the original raw database for the air quality index scores before the unuseful columns of data was removed. In the second image is a portion of the raw database for preterm births from the Kids Count Data Center. In the top image is the summative data table of the air quality index scores and the preterm births using the 14 summative data points. The summative data table was visualized using a double y-axis summative graph. The bottom right image is a scatter plot with a linear trend line to represent the correlation between the two variables. As the majority of the raw data points move to the right of the x-axis, it also moves up on the y-axis, determining a direct positive correlation. Although a visual was given for the correlation between the two variables, a numerical approach would be more beneficial. So, a Pearson's R correlation coefficient was conducted. The R value given in this analysis was 0.74. 0.74 lies closer to 1 than 0, so it represents a direct positive correlation. Since it lies very close to 1, it's also a strong correlation. The majority of the trends discovered before creating any graphs or conducting any tests represented a direct correlation, however some represented an indirect correlation. One significant limitation of the data was the lack of having prenatal care as a control in the data. Prenatal care is a major factor that may affect the outcome of a pregnancy, so since it was not able to be used as a control, it increased the possibility of it being a third variable, decreasing the accuracy of the data. The R value of 0.74 found after the Pearson's R correlation coefficient was conducted determined that the hypothesis was accepted. A significant piece in the background research was found that supported the results of this analysis. In a study conducted in the Department of Mathematics and Computer Science, it was found that after adjusting genetic factors, a higher rate of preterm births occurred in air quality index scores near 50. In this analysis, the state with the highest number of preterm births had an air quality index score of 46.2, which is near 50. To increase the accuracy of the data, an increase in the controls would be beneficial. It would also be beneficial to have more trials in the analysis. An interesting expansion in this analysis could be by focusing on different trimesters of a pregnancy when exposed to fine particulate matter. Exposure to fine particulate matter during different trimesters of a pregnancy may impact the embryo differently. Here are the references used during this project presentation. I hope you enjoyed this presentation. Thank you for taking your time to watch it.